reinforcement learning. So I'm sure many of you might have heard till now that all the new versions of the LLMs, for example, the DeepSeek and more recent versions like the Anthropic Claudes, etc., are all being trained using different methods of reinforcement learning to give better results, right? But you might be curious, like, what is it, and how is it beating all the provisional models like the GPTs and Geminis? So I will try to explain it in the best way possible. So now, by now, you know that. I'm sorry. Okay. So by now, you know that in the traditional, or I might say the core ML that we have learned till now, there are different type of ways a machine learning model can learn from the data. Uh, for example, it can be a supervised machine learning method, can be unsupervised machine learning method, it can be self-supervised, it can be semi-supervised, and many more, right? So one common thing that you can observe here is that you always require some data, and if I might say more preferably, some at least some amount of label data, because I'm not talking about unsupervised. It does not need any label data, but still it needs some type of data which you have some uh, preconception, like you have some preconceived notion about the data, that you know what the data stands about. For example, if you have a self-driving cars data, not self-driving cars, I'm sorry. For example, if you have any type of, for example, news articles data, and you are using unsupervised machine learning models to cluster the news articles of the same topic, right? That all the topics talking about the hydrogen powered cars, etc., all need to be clustered together. But you have some preconceived notion that all the hydrogen H2 symbols in the articles as mentioned, these stand for the news articles that I want to cluster. So you have some preconceived notion, right? But reinforcement learning is completely new dimension, and it's a completely different game. Let me explain how. So in reinforcement learning, there is no data. What I mean to say, there is no data which is labeled. Now, you might say that then why does it stand in the unsupervised machine learning algorithm? Because, as I said, in unsupervised also you need to have some previous prior information about the data that what you want to do. Here, there is no information that what you actually want to do. Like in unsupervised machine learning models, the models have some fixed mathematical equations. They have some fixed mathematical equations, some fixed algorithms. The algorithms are fixed. That, okay, for example, in DB scan or a type of k-means clustering algorithm, that I have to minimize this loss function. So this formula is fixed for the k-means clustering algorithm, which is a very popular unsupervised machine learning algorithm, right? But on the other hand, reinforcement learning methods do not have any type of equations, or I would say they do not have any fixed type of algorithms. So there is no way that a machine learning model can learn from the data itself while being pre-programmed. So instead, RL, that is the reinforcement learning methods, they actually happens like this. There's a computer which we popularly call as a reinforcement learning agent, which needs to take some actions. So this reinforcement learning agent takes some action, AT, on the environment. Environment, I mean to say, the space in which it is playing or learning something. For example, it's learning to play a chess game. So the chess board is its environment. So it takes some action from the environment. And for example, just assume that its pawn cracks the rookie. Cracks the rook. That is, defeats the rook or kills the rook. Okay, whatever you want to say. Then this means the move that the reinforcement learning agent did, the action that it took, that the pawn should move to g9, for example. This action will give a positive reward of plus 10. and the state is changed, right? The environment state is changed. So this state moved from state 0 to state 1 due to the some action A0 or A1, whatever you want to call, and it gets a reward R1 in return. Now again it will take some action, but the next time it moves to diagonally to kill the queen, that king gets captured and there's a checkmate position. So now the next reward will give -10, and still the state will be changed since the pawn has out of the board now. So another action A1, previous action gave a positive reward, another action A1 gave a negative reward. And so this is how the sequence repeats. This is like a loop, right? So what you can observe here that is different from supervised or unsupervised machine learning algorithm. You do not have any preconceived notion, like you do not have any type of fixed algorithms that by which way the actions should be taken so that the model will always win, because you know that the chessboard has that 64 squares, and they're almost that they're not innumerable, but still they're accountably infinite ways to win a chess game in a particular scenario in a particular orientation, right? So this what does this mean? There's no way a human can label all the chess games and give a value to each of these actions, that if current action is this, then take the next action, then take the next action, then take the next action. Like next action can be like move the pawn to g9, then the rook to g11, then the uh, bishop to b2. So this sequence of action can change based on the orientation of it, because you do not know the what the other player is playing or what the environment. Here the environment is like a live thing, it's living, so it can behave in any random fashion. So is even if any human labels the data, it might prove to be very harmful in later stages, because the environment keeps on changing. So there's no need and also no way that you can label all this type of scenarios like a supervised or unsupervised machine learning algorithm, right? And why is this different from unsupervised? Because there's no way that you know which action, because since there is no particular set of actions to take to reach a particular goal for convergence, so there is no fixed algorithm that you or loss function that which you want to minimize. So this is how it's different from the traditional machine learning and deep learning algorithms. Now, I will try to explain to in a more easy manner if you're still not able to understand. Imagine in supervised machine learning algorithms, how does a child learn? Imagine you have a baby or an infant who is, this is you, okay? You're the father, mother, anything. And this is your baby. Sorry, it's more, it looks like more like Frankenstein. Um, so your baby is learning about A for apple and B for banana and so on and so forth. Okay. Hmm. And now, now in supervised machine learning algorithm, what will happen? You have a label data set. So you will teach the baby A stands for apple, B for banana, and then the baby might learn that okay, whatever the app letter starts with, that is the word. So he will now say that C stands for cow. Okay. But in case if he said that C stands for dog, you will say, hey baby, this is not the point. You are doing a mistake, and this is how the loss function works. Okay, this is under your supervision. That's why I call supervised machine learning. The baby is trying. If the baby makes an error, you are there to correct the baby, right? In reinforcement learning, there is no such thing. There is a human, but imagine he is doing some other work. Of course, humans are always required, otherwise, the AI system can become very non-ethical and dangerous in business. But imagine he's a father and he's washing the dishes for now, and the baby is learning on its own, okay, to walk. So, if the and the baby and there, no, for walking, just imagine how many when you started to walk. I mean, you can't remember that time, but just imagine if the baby learns to walk, how many different type of orientation it has to set. He or she has to set the position of the elbows, the position of the knees, the position of the toes, the foot, the body posture. The baby has to like set many different things. Then it knows how to walk, and this can also change with the environment on the type of floor he or she is walking. So this here you can see that the whole environment is like a living thing. The whole environment is changing from time to time. So the baby has to take different orientations at different instant time, and this might keep on changing every second, every moment of the whole episode, right? So since there are so many large number of parameters and the environment is a living thing, so the baby has to learn from the rewards it get. If the baby falls, he or she will get a negative reward. If the baby keeps on walking, he will every second get a positive reward. And when the baby falls, he know that okay, in this scenario on the wet floor, elbow should not be greater than 60 degrees. It's just like a mind mapping thing. And this is how it learns to walk. So you, without any human supervision, the baby is learning to walk using the cases of negative reward, positive rewards, and then it knows in different type of environments what is the orientation of the things it needs to take. So reinforcement learning is just, and technically it's not a thing, but if I want to convey to the easier level of audience, I will say that it's a very complicated version of this machine learning. Here many different parameters have to set all together simultaneously in different type of environments, and that is why it has to learn from the rewards, because the environment is so large, so vast, so many simulations, so many orientations of the same environment are there, that is not possible for a single human to label all this and make the reinforcement learning agent run through all the iterations of the simulations and learn from it. So that's why we have come up with a new way, reinforcement learning, where the model on its own autonomously takes some actions, and based on the rewards it learns to get what is the best in a particular orientation, what is the best action to take, so that my reward gets maximized. Now in some other videos I will tell you how this rewards get calculated. Actually it's not a reward. I just give you a glimpse that it is a discounted reward function actually. So this, so that the model does not overfit. There are different value functions, there are different q value functions, and rewards are not single entities, like they are not numerical quantity, they are more like a function. Okay, for example using angular velocity, etc. For example self-driving cars use this type of formulas. So reinforcement learning, one thing keep in mind, that it is very maths heavy. That's why the work is still going on this field, but I will try to break down every difficult concepts in RL to make it easier for you to understand. Thank you.